Hi everyone, welcome to MathSpellBook. I'm your host Peter, and basically we are going to do some maths today. Of course it is called MathSpellBook, so you guys probably know that it's basically revolving around mathematics, but also I also do physics as well because I'm curious about both subjects, and we are multi-streaming from Twitch to Twitch as well as to YouTube. So this is my first time actually multi-streaming with this channel, so if you're stopping by in YouTube and this is your first time, welcome. Hopefully you guys are into mathematics as well as physics, or if you need like a little study stream to basically keep yourselves occupied, you know, just chill with us and we'll just enjoy each other's company. Oh, hello, Daniel Dan. Nice to meet you. Welcome. Recommended me this channel, so I decided to follow it. Oh, I have to thank Dan. I have to thank Don when he comes in. But thank you for coming in, Daniel Dan. It's great to actually have you here. I'm guessing you're into maths as well, math and physics, I think. Or do you just basically just want a little study stream to keep yourself productive with the projects you're doing? And what's the best part of your day? What's the best part of your day so far, guys? Hello, Sascha. Bonjour, Sascha. More math than physics. Gotcha. Yeah, I'm the same way. Because like I love physics because of how mathematical it is. So I mostly want to learn math so I can understand what physics is telling us. So I guess I just learned math so I can understand the physics in a way. But I guess it could be the other way around, right? Anyway, enough of me yammering. Bon après-midi? I don't know if I pronounced that right, Sascha. I'm learning French from you as well as maths. Yeah, so I think we're gonna basically just start off with like simple stuff. Well, I say simple stuff, it's not simple, but I think calculation based, I probably should say that. I'm gonna start with calculation based maths, and then if we have time, we'll probably move into equivalence classes, because I've been more curious about equivalence classes. So that's the thing that's motivating me to continue on with like maths. So did I pronounce it right, Sascha? Oh, good afternoon. Okay. I don't know if I pronounced it right, because I think it's like pronounced like because the way I read it, because I think like in French you don't pronounce the last S that much, right? Bon après-midi. Like actually, it's because of Sascha, I sometimes feel as if yeah, we don't. Okay. Yeah, because I noticed that whenever I listen to it's a song from a French show called Lyoko. I always listen to the opening, and I noticed that whenever I see the words in French ending with S, I notice that they don't pronounce it, and I'm like, oh, that's interesting. Because I think I also learned from a show that you guys don't pronounce the H as much, right? Like if it's at the beginning of a word, you guys don't pronounce the H in a word, right? If it's at the beginning of a word. Or salud. Oh, salud. Oh, okay. Interesting. We also find the N oh, bon après. Bon appetit. Oh, okay. Bon appetit midi. Oh, okay. Interesting. Yeah, I also noticed that too, actually, which is really interesting. Anyway, I think we're gonna do a little linear algebra. I did learn about projections, so let's see if we can do this. Okay, let me grab my pen here. So we'll start off with what wakes my brain up with math, a question. So question number 1, find the projection of vector v onto, I think that's line L, so line L is C is an element of the real numbers, and V is 1, 5. Okay, so if I remember correctly, the projection of V is supposed to be, there's 2 ways to write it. Because it's like V dot product of I gotta make sure I don't mix things up here, because I think it's vector X because I remember it's the vector onto casting the projection, and then like at the bottom it's supposed to be the magnitude of I think the vector that's being projected onto. So because I think the L is supposed to represent I think this vector is supposed to represent X in this case. So let's actually like draw it, so maybe we'll get a better, because sometimes when I draw it, it makes it a little bit easier. So it's 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so the vector itself is 1 to 5, so it's up here. Okay, so this is vector V, and so if this is 1, so this would be -2, 0, so it's right here. And I'm guessing so if you multiply, so it's always going to be 0, so it's going to be practically on the x-axis, I think. Yeah, because it's always going to be 0 if you multiply, because it's going to basically be boom, 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 boom. Yeah, because this one's 0, so I think it's going to be... So the projection is like right here somewhere. I think the hardest part for a non-French speaker to get used to is the gender system. Yeah, I think that's the same with Spanish too. Like when you learn Spanish. I learned Spanish and Italian. I learned Italian in community college, and I learned Spanish in high school. I couldn't really get used to the gender system, like when it came to like certain words. La livrier and les livrier. Oh wow, it's like they look like the same word, but they're totally 2 different words based on the I guess either la or le. Interesting. Did not know that. Yeah, like masculine and feminine words. Yeah, that was something I couldn't get used to. When I learned Japanese, I was so happy that they didn't have that type of thing. I mean, they do have like with pronouns, but like it's not as prevalent as like say like a single word in a sentence. Like conjugation is also a difficult thing. Like, you know, like when it's like Spanish, I think it's like, you know, like you have to change the verb depending upon who's talking or what you're talking about. Okay, so I'm thinking this area would be like X, so I remember writing in my notes, it was like, you're doing the dot product with the vector, and I think, and then the vector here, and you also have to do the dot product with, I think, like these two, which you can also translate this as this over. Now I don't know if there's a square root here. I mean, not a square root, squared here, because it's like it's two of the same vector. I think that's how it works. And then V here. Or was it U for a unit vector? I'll probably recall it later on. I don't want to like look into like my notebook because it's in my room. I didn't bring it with me. So the dot product. So which is it? Okay. So 2 plus 0, 5, and yeah, I think that's how it is. Then it's this one, so I always found funny you guys have words like read, which change the pronunciation whether you use present or past tense. Yeah, it's I think it's just one of those things with languages, like, you know how in English we have like ph is an F sound, is like an F sound, and like we said photographs instead of like protographs or something like that. English is hard. -2, that would be 4, and then that would be 2 underneath, so we have a -1 here. We multiply that with the vector in question, which gives us -1. So it says find the projection of V onto L. I think I didn't do something right. Yeah, I think I didn't do something right, because none of the answers I have matches this. So back to the drawing board. I think we mixed up vectors. That's the only thing I can think of that I did wrong here. Okay, so we got 2. Okay, I'm making sure that I wrote the numbers correctly. So I think we have to do it from this vector instead of this one. So let's just erase this, because now I'm trying to base it on my memory, so that way it will solidify in my brain. It's supposed to be projection of, let's see, projection of V onto L, which is here. So we want this area here, but also we want like the length of this here. So we'll do the opposite way. So we'll switch the vectors. So I think this and do think with multiple choice, it always helps me go to the right answer. But of course, like when there's no multiple choice, like sometimes you can like mislead yourself. And times that. Okay, let's see if this works. Okay, so we have the dot product. I mean, the dot product's gonna still be the same. So it's gonna be 0. And then right here, since we have V, so it's gonna be 1 plus 5. So we're left with, ooh, that doesn't look nice. I'm already seeing the result is like 26. Reducing that, it would be like 13. And you multiply that by yeah, that's not right. See, sometimes I have to learn more. I have to remember more and learn more about what I think I'm learning. So I am mixing stuff up here. But that's why it's called practice. Let's see, projection of V onto... So we got the visual. Now the thing of it is like trying to remember the way to set this up. Because V is the one that's actually projecting the shadow onto L in this case. So maybe it was the way I wrote it before. Let's see, yeah. Then we would end up with 4. Then we have to multiply that by maybe it's not V we multiply by, maybe it's X, because then this would turn out to be -1, and then but then we still have -2. Guess I have to look back in the notes and see what I'm missing here. Okay, I remember the formula correctly. Here they're showing an example, but I feel like I might be cheating myself if I look at the example. But let's see if we can... I'm probably going to look at parts of it, so... Okay. So the way they did it, I think like maybe we're doing the wrong method. So I think like two methods exist. So I think it's like this and like this and like this. So I think there's like two methods. Because maybe I thought they were the same thing, but they are not. So so we did the dot product correctly. So it's like plus, and then we're supposed to do the dot product of these two. So, so here, then plus 0 times 0, which leaves us with -2 over 4, which gives us -1/2. And oh, we have to do it by x. Okay. Okay. All right, that makes more sense. Okay. So basically, you only use the vector that projects on once. Okay. Maybe I have to do more of these problems to get a better gist. Okay, so then you multiply that by... That makes more sense. Because then you would end up with this. Which is one of our answers. Okay. Check that. Yep, that's correct. Alright, x1. Okay, I think it's about the same type of problem. Okay, so now we can solidify it more. So, find... And if anyone's watching this on YouTube, type, if you would like to talk in the chat, please talk in the chat. Even though I'm working on like math or anything, and it might be your first time stopping into the live stream, it's okay to like type something in the chat. It won't bother me. I usually think of my streams as sort of like an interactive, like, I guess like an interactive like work session, and you guys just basically just come in and see what I'm doing. It's like, think about it this way. Imagine your friend is like is an inventor, and they love to invent things, and then you just drop by and they don't mind you visiting, and they're like, hey, look at my latest project, and you know, and they're like willing to like explain their project to you, or like they're like willing to like work while talking to you at the same time. Think of it that way. It's sort of like you're just like, you guys are just like coming into my workshop while I'm working in the backyard. Think of it that way. So don't feel like you're bothering me or anything like that, because the point of math is also to have fun. Okay, so we gotta do a projection of V onto L, which I think is the same type of question, right? Yeah, V onto L. So in this case, we have to do this. This onto X. Projection of L onto V. Or V onto L, I should say. So this time we have 3 plus 2 times -2 times 3 plus 1 -1 times -4, and then the cross product of these two, so this will be 9 plus so we have -16. Oh, well, yeah, we have +16 plus 9, and then we have negative 6 plus 4, so negative 2 over 25, and that multiplied by so it looks like we're gonna have a fraction result. Hey, happy Wednesday, Zach. So for my Twitch viewers, I will give a shout out to Zach. If you guys are not familiar with Zach, he is another math streamer. Unfortunately, I can't give him a shout out on YouTube. I would like to, but unfortunately, I can't because I can't type anything in the YouTube chat from my interaction point, I should say, because I'm just it's only read only with the program I'm using, so I can only see your what you type in chat in YouTube, unfortunately. Okay, that was weird. Let me see. Maybe I gotta open a new docs here. Oh, here we go. That's weird. Like, the program has like a separate Twitch chat for Twitch chat. That's just so bizarre. Alright, so now give Zach a proper shout out. There we go. Okay, cool. Oh, no, Zach, you are just like, you are very kind, because you are willing to teach your mathematical knowledge to all of us that love math, so thank you. Now where was I? Oh yeah. But how are you doing, Zach? What's the best part of your day so far, my friend? So we have, that would be negative 6 over 25, and that would be 8 over 25. So we have negative 6 over 25. Okay, we do have choices. That is good. Can we reduce these? I want to double check to make sure, because sometimes I forget to reduce and I also forget to put a sign. So I think we can. I think we're good here. So check answer. Yes, it's correct. Cool. Okay, this is the last question, and it's the same. Okay, so it's the same process. So we're solidifying this in our head. So sometimes for me, I just want to do at least enough questions to basically feel as if like I'm getting the basics down. But of course, if there's more hard work involved, like such as I have to know more methods or more techniques involving a subject, I will put in the effort to actually do those exercises. But if it's like, let's say if there's like 5 methods within like one chapter you have to do, I'd rather do 3 problems involving the basics of those methods than just do every single problem within the chapter, because I feel as if like, even though you do solidify it a lot better that way, it just feels as if it's more of a trudge to do that. And there will be problems that you will feel like, oh, I don't remember this. It's like me whenever I try to do things like integration, because I would forget, like, say things like what is the integral of let's say like 1 over x or something like that. Stuff like that. I think like the derivative that I would forget the most is what is it? I think it's the natural log of like say like a to the x power or something. It's something around those lines. I don't remember what was the exact differential derivative that I would forget, but it involves like the natural log or log of something. Usually those I forget. The only one I remember for logs is like, I think the natural log of x, if you take the derivative of that, it's like 1 over x. That's the only one I remember, but the other ones I always forget. Okay, so projection of V into L. Okay, so in this case, 6 times 2 plus 4 times 2. And then we got to do 6 times negative 6 plus 2 times 2. And that multiplied by 6, negative 6 to 2. So that gives us negative 12 plus 8. And that gives us 36 plus 4. Let's carry this up here. And so that would be negative 4 over 40. Yeah, that's 40. 16. Not 16. Negative 6 over 2. So we can reduce that to negative over 10. And then be 6 over 10. And then negative 2 over 10. And we can reduce this to 3 over 5. And negative 1 over 5. Okay, so let's see what choices we have. Okay, I want to double check to make sure we did the problem right, because sometimes we do make arithmetic mistakes, so I have to get into the habit of checking everything. So that's equal to 12, that's equal to 8, that's correct. That's equal to 36, and that's equal to 4. That's correct. And then, yeah. Yep, that looks good. Negative. Yep. So negative 6. That would be positive. And this was positive, so that's negative. So then, yeah, there we go. Everything looks a-okay. Now, we do have the answer in the choices we have, so let's see if we get correct. Yes, we did. Awesome. Like, I'm not showing like the questions on the screen because of I'm doing it from Udemy, and I want to be able to, like, if you guys actually want to take the course that that I'm doing on Udemy, just ask. And I'll probably like put a link to their Udemy, because I think Udemy is like a really good resource for me, because you learn a lot from Udemy, and they do provide a lot of like people with different teaching methods to give you like the right amount of courses to take for whatever it is you want to do, whether it be math or science or even computer science. Speaking of which, I will be right back, guys. I just realized I have to refill my water. BRB. Okay guys, we're back. Sorry to keep you guys waiting. Anyway, let's see what's the next topic in this. Because so the thing about the course that I'm taking is that everything is divided into sections. So I'm on the section on transformations, and it looks like we only have one last section of this to cover, which is the one I'm on now. So awesome. So this one is composition of linear transformations. Okay, so I will definitely take notes on this, and I will try to simplify my notes for myself. And if you guys manage to follow along with my notes, thank you for being able to follow along, because sometimes my notes can be a little bit haphazard. So if you're able to follow along with me, I'm glad I was able to help go into the concepts for you in a way that makes sense to you. And if it doesn't make sense to you guys, just let me know in the chat, because maybe I'll try to simplify it a little bit better, because my notes are just basically what my brain is thinking at that point. I'm pretty sure you guys, if you've taken a class, you probably had to face that mainly. Okay. So let's see what we got. So we got two visuals here. One with X. I'm just drawing these just in case because usually visuals in math is like a plus, especially for me. And I think that's M, so okay. Hey Mavort, do you save your notes? Usually for me, even though I write notes, if it's in a notebook, like a solid notebook, I do save them. If it's on software like this, Excel Draw, I sometimes save it on my computer. But usually with me with notes, I notice that I don't look back at them that much unless I need to. So for me, it's I try to write notes because it basically gives me, I guess, a way to formalize everything in my head. And once I think of a way to actually phrase it better in my own words, then I'm able to reflect on how this process goes. So, yeah. Why do you ask, Mavor? And actually, how's your day so far, Mavor? I think it's been a while since I've seen you on the chat. Hopefully your day's going smoothly. Okay, so let's see here. So let's say here is S, and then they give us another example, which is another, ooh, that looks too big. Let's just make it a little bit smaller here. Then we'll do this. Actually, this should be in here. So which is transformation of S, then we have Z, and then we have R, t in this case. Then we take that. That's transformation t, which is t from y to z. Which is t s. Okay. So these two are both linear transformations. Yes, I'm not a regular viewer, but I'll drop by at least once in a while. I'm glad you are able to make time to stop by, even if it's only for like a few minutes or a few seconds. I always appreciate it, Mavort. Good day was running for 10 kilometers. Oh wow! Congratulations to you. That's a really far run. I don't think I'd be able to run that much. I love walking more than running, because usually when I run, I worry about cracks in the pavement, and if I trip, then I fall on my face, and it will like hurt really bad. I'm trying not to write the notes because usually when I read a textbook or whenever I do note taking, I always have a bad habit of rewriting everything that's from the textbook, because I'm like, oh, the textbook explained it in such a good way that I understand, so I'm just gonna write it the way the textbook phrased it because I understood it. But at the same time, that doesn't become helpful because it doesn't let my brain remember it better. So you're doing linear algebra this time, it seems? Yeah, because I noticed that whenever I try to do, I guess, more complicated math, I tend to read more, and if I read too long on stream, then basically I have to get my brain working on actual problems. And I don't want you guys to get bored with me just reading stuff. Let's see. But of course, with study streams, like I don't know how study streamers do it. Like they are able to study for so long, and like not show that they're sleepy. Let's see, friends. Because I'm guessing they're trying to make something similar, like with composition of functions, like make it look like have a similarity to it. Because I do see a similarity with this as a composition of functions, but this is a composition of linear transforms. Okay, so now they're showing us the rules, or the way it's like you can present them. So in this case, if we have s the vector y xy, that is equivalent to after we complete this last session of linear algebra, we'll probably move on to, like, I guess maybe like a little bit of equivalence classes, because I did get intrigued by equivalence classes, so I feel like I have to do more my own personal research. I call it research, but of course, like, it's all in stuff that probably is already well known within math, so I consider it just like basically just studying more on the basics that mathematicians already know. this. Okay. And I think they show, oh yeah, it's also closed on scalar multiplication, so we might as well write that too. Actually, like, the reason why I would probably remember these like better is because it's like, oh, it's the same rules as a vector space. Well, not entirely, but like I guess like with math, if you understand, like, I don't want to say understand because, like, you know, I sometimes don't know if I fully understand something, but once you have I think the basic knowledge of like the way how a certain math idea works, you compare it to you start comparing like newer math ideas with older math ideas you learned. So sometimes I try to break it down to the point where it's like, oh, I shouldn't have just the basic knowledge of the previous idea to reflect upon this new idea that I learned. I should like try to break it down even further where it's like that this new idea of math that I learned, even though it's based off an old idea, it stands as a unique version of itself in a way, if that makes any sense. But that's really hard to do. And I think that's why like a lot of people say you have to learn the basics like beforehand. Like you have to learn about limits before you do differentiation. I mean, that's like the basic train of thought, but some people have different ways of going about things and they just find a way to actually learn it in a different way. Which is what they should do, because it's like, it's better for them to actually think of it the way they should, the way they feel as if they can for themselves to make it easier. Let's see what else. Yeah, there's a lot of info in this one. I'm trying not to write so much. Your proof looks good so far, as you have shown the composition is linear. So my question for you guys in chat, like whether it be on YouTube or whether it be on Twitch, my question to you guys is that when something is linear, does that mean it's able to follow these rules such as like, you know, vector addition and scalar multiplication in a very simple way, where it's not overly complicated? Like say if something is non-linear, like you basically can just have like a how should I say, like a formation like this where it's like a vector, something like this very easily, whilst like say if you had something like, you know, a squared or like that, and cube or something like that. Like that's my question for chat. Is like, is it, when it's linear, is it like it allows you to do certain things, like allow you to write it like in this type of fashion without having to deal with like extra cumbersome like terms here? Or am I just like oversimplifying it? I'll leave that question to you guys to contemplate if you need time to. Let's see, a function f is linear if one f c is equal to, and okay, so it is like that. Okay. Okay, yeah, because that's what I was been thinking about this whole time when I was studying a little bit of linear algebra, is like what makes, and also like with differential equations, like linear seems to be a very important definition within like certain setups, and I was like wondering what makes linear so special compared to like non-linear stuff. And I'm thinking it's probably the way you break things up within like certain expressions, because I think the way you break things up with linear whether it be linear equations or linear functions or whatever, like they're probably easier to break up compared to like non-linear things. In one day you can think of it as a straight line that goes through the origin, for example, is linear, but f of x is not. Is it because it just has a constant plus 1, the constant plus 1 in it? Is that the reason why it's not linear? I mean, even though it would be still a straight line, but it's not linear in this case. Like when it comes to like an equation setup. They're showing us as a... Okay, so now it's like a... What happens if we have S as a matrix vector product? I gotta bring this up like this. So let's say S is equal to this, A, okay, A is M by N matrix, and let's say T is given by the matrix, and B is an P by M matrix. Correct. You can test it if it satisfies the condition for linearity. Okay. Yeah, like linearity, I feel as if I don't fully understand it yet. But let's see here. And because the composition, so we can write it like this. So I think we can just write it like this, like that, which is equal to Cx, where C is P by N matrix. Okay. What I find very interesting about matrices is that, like, when I was actually learning more about linear transformations, I found it so cool that matrices feel like they were like the space that you put a vector on, but then the vector gets manipulated based on what's in the matrix. I think that's really cool. People often still call these types of functions linear because they look like a line. Yeah, I remember reading in a book that linearity doesn't involve things, and it doesn't really, I guess, it doesn't really revolve around lines as much as people think. And everyone knows what it's meant, but strictly by definition is not linear. Okay. Yeah, because like when I think of like something linear, I think of the line, which is like, you know, what you would think of from algebra. Or like what your algebra teachers would teach you. Okay, so I think that's basically, so they give us an example here. I don't think I'm gonna write the example because I don't want to take like this person's like worked example in here. Because I'm just going to take a quick glance at it and see how it works. So you're going to have to use that. Okay, because the way it looks like is that you have to take the way they set it up. Then you're going to have to use the identity matrix. So we have to create like the matrix with like with the function, and then basically we use the identity matrix to simplify the space so it makes more sense to us. And then we're gonna have to do the arithmetic. Okay, so I think like the primary objective is to set it up so it's like this. So we basically have to get A and B first. My former linear algebra professor used to be very strict about this, correcting people who said that 2x plus 1 would be linear. The right word for this type of function is affine. Oh, interesting. And what would that mean, actually? I'm guessing it's probably like something on the borderline between like, you know, something that makes a line in the graph but not really linear. I'm guessing that's what it means, Mavort. I just want to look this over so I can get a better idea. So I think what we have to do, so according to what I saw in the notes, you have to take the setup of S and T of X and transform each of them with the identity matrix to get A and B, which is in here. And then you basically have to get that, you have to multiply and then multiply A and B to get C. Ah, I see. Now I learned something new. Thank you, before. So affine is basically just that setup. Okay, that makes sense. Well, Thank you for sharing that knowledge. So if any of you guys are taking linear algebra with a strict professor like what Mavor had to deal with, now you know. Linear is basically like, you know, a times x, and affine is basically a times x plus b, like that type of setup. So big thanks to Mavor for sharing that with us. Let's see. So the way this question is set up is that they give you an sx and a tx, and then they also give you a vector x to work with, but I think vector x you have to work with at the very end. So I think let's try to see how we can do this. Okay. And if you guys like math, physics, or you just want someone to chill with while you're doing study or project productive work, you know, if you're watching this on Twitch, please drop a follow. And if you're watching this on YouTube, on the YouTube live stream, you know, hit the subscribe button. It really helps me, really motivates me to like make more live streams for you guys. In addition, I love to give people more atmosphere to like do productive work that they need to get done, even if it's not math related. Like if you're an artist and you need someone just to chill with and like chat with while they're working on something that they're passionate about, feel free to drop in. You talking to me doesn't bother me at all. It makes me feel as if we're like in a workshop doing our own personal projects, and you know, we all want to see you succeed in whatever it is you're building, whether it be something for like your business, or whether it be for something for your studies, or both, doesn't matter. Or it's just something that you just really want to build because you feel like this is something that you want to build. We all want you to get the things that you wish to create in this world. It's a bit inconvenient that you're not sharing the exercise, because the way we can only guess what you're trying to do. Yeah, the reason why I'm not doing that is because someone took the time to make a course on Udemy to like write the notes and everything like that, because I don't want to like write entirely the stuff that they wrote, because one, I don't want to copy their notes, and two, like, you know, if someone wants to take the course on Udemy, they can take it. I mean, of course, like they have to wait for the Udemy sale to take off, you know, because this person actually gets like they get paid for anyone that takes the course on Udemy, so you know, I just try to like basically put that, yeah, like, you know, like I don't want to put like everything of their work on. Yeah, Udemy always has a sale. Yeah. So where was I? Oh yeah. Okay, so we have these. Now we will do what we can. So I think now we can do. So we're gonna have to take the identity matrix, which is this one. And the way we do this is that we have to do it column by column. So we gotta do it like this, and then basically -1 plus 0, and then that's equal to 3. That gives us -1, 3, and then for the other column, do it like this, which leaves us with 0 and plus 1, right? Yeah, and then this one's also 0, so that means we're left with 0. So 1 over 0, 1 and 0, 1 and 0. So that means the matrix itself is or in this case we can just write it as we'll just write it as A. So the matrix A in this case is Okay. Now we gotta do t. So t in this case. And this is equal to 1 minus 0. And then 2 times, so that's 0. So this is equal to, okay, it's not a negative. Okay, cool. And then that, okay, so that's the first part. And the second part is basically that's 0, and that's, so it's 1. And this one, negative 2. Trying to make sure that that's correct. So basically that makes it 0, and that one makes it 1, negative 1. Okay. So this one is, yeah, that looks right. So b is equal to 2. Okay. Well, I'm trying to break it down in steps that I can see, because the thing of it is that, like, I know I'm probably making it overcomplicated, but at the same time, like, for me, it's just better for me to organize it in my head. And I think, like, whenever I see, like, a way to make it more simpler, I basically just, like, think about it for a deep moment. Because for me, I haven't solved the problem yet, so that's the reason why I'm doing it in this long-winded way. What's up, Mavor? It's like, what is it that you see? Hey, Sasha, welcome back. Oh, you just needed. Oh, you just wanted to copy what I was doing. Okay. Welcome back, Sasha. Welcome back. Okay, so the way we form this is actually, I should move these around. I shouldn't have set it up like that. So, and this would be X here. So B, and then this one. And what we have for X, we'll leave that in the final step. But we'll just write it here so we don't have to keep scrolling back up and down. Okay, so now we gotta multiply these. This should be fun. So it's 2 by 2, it's 2 by 2, meaning we're gonna have to do this times this. At least it's 4 by 4. Well, I mean, at least it's 2 by 2, so it's like not too much. I always write every step, so I know I could probably do it in my head, but I'm like, no, I don't want to mix up numbers, because every time when I do it in my head, I always mix up something. That, okay. And the next one plus okay, so we got -2 plus -3. So -2, so -5. And we have 2 plus 0, so it's 2. 0, -6. And this one, it's just all 0. So there we go. I should have done a section of my master's thesis in the next 50 minutes. I will just have to write a conclusion and intro, and we'll be done. Nice. Also correcting grammar and spelling mistakes. Oh, okay. Alright, so now I think we got that one. And I think we have to multiply that with is that the right way? Yeah. And is that the way it's displayed in the question? Yes. Okay, so now we gotta do this. Plus and plus 1, 0. -7. And this is -6. Okay. Oh, you typed something before. Welcome back, Sascha. But like Sascha, yeah, I read what you typed out. It's like, yeah, I mean, like, at least you're like starting to write everything for your master thesis. So I wish you the best of luck on that. You know, like grammar, like correcting for grammar is usually like the hardest part. Look at the expression. You can also write it as +0. That way you see the matrix immediately. Okay. Let me see here. Let me look back at what we have here. I mean, I see what you mean, Mavort. Yeah, because like plus 0x2, and let's see if that makes the final result here. Okay. Yeah, I'm trying to compare with my answers, that's why. So if we did the same trick the way you described it, so this is, so then it would be like 0, 1 here. Oh, I see. That is very clever. Very, very clever. It took me a while to actually have it click, but that's actually a really clever trick. So, according to Mavort, guys, is basically like if you look at the way this matrix is set up, I think this is a useful trick we can learn. So, thank you, Mavort, for actually showing that. So we have like this. So according to Mavort, we leave it like this. We write it like this, but for the second one, because since we have 3, it will be plus 0x2, right? And what we have for A in this case, it's almost similar, because what we're doing is that we're multiplying by the identity matrix, which is basically just giving us this. And for like, if we apply the same principles with T, so we have minus x. So this one, oops, I should probably write that better because that looks squished. So plus, oh no, that's a minus, oops. So minus 2x. So this one's 2x, so this one would be 0, 1x. And then 2x. And when we look at b in this case, since we are multiplying by the identity matrix, we have basically like this. And that's a very useful trick, actually. That's something to keep in mind. Thank you for showing us that one more. That actually probably simplified the work much easier. I think the reason why I did it this way was because, like, one, I saw it in the notes, and two, it made more sense to me. That's the reason. That's how matrix multiplication works. I recommend watching The Essence of Linear Algebra. Yeah, I mean, I have to probably watch that over again because I have seen that one before. But thank you for reminding me of that before. Okay, so we have -7 and -6. So is that in here? I think I see it. So let's check. Yes, that is correct. Now we're on to the next one. So I guess we're just basically doing linear algebra the whole entire time, guys. So probably next week. Like, I know I didn't stream like at all for the past 2 days, but like a lot of stuff was going on. So we will be back next week, and we will be streaming on both YouTube and Twitch. So hopefully the Twitch stream and the YouTube streams look okay for you guys. Essentially, the 4th video of the series is relevant here. Gotcha. Yeah, because like for me, like whenever I learn things like math, I don't really see like I'm not very clever when it comes to like seeing like, oh, there's a trick here. You can just do this to solve this much faster. Like, I never catch on to the faster math tricks. I always do the things that seem standard. That's why I think everyone's smarter than me, because like if they find the trick and I'm like, oh my gosh, I didn't see that. That's clever. Oh, hello. Naveen. Welcome in, welcome in, welcome in from YouTube. Hopefully you're doing well. What's the best part of your day so far? Okay. And question to you, another question to you is, do you like math, physics, or you just need a productive stream to keep you busy? Either way is fine. Because I know not everybody likes math or physics. Okay, so what we got here is, so we'll do what Mavort suggested and basically just keep things simple. Okay. Then t of x equal to see here. Actually, like, since I'm actually doing multi-streaming, I have to figure out how to combine both chats together on screen for you guys. Because the only chat that's on my screen is my Twitch chat. But I will definitely, but I still have like your chat, like anyone on YouTube. I still have the chat like open on my computer, so I can see what you guys are typing. So don't worry, don't feel like you're left out. I just don't know how to combine them yet on like the main streaming screen. So that way we can see everyone's input. Hopefully I can figure out how to do that, like probably by the next live stream next week. Okay, so now let us move down a bit. So let's say it's like this and like this. Then we have 0, 0, -4. This one's -1, 1, and then 0. So we'll say that this one's A, and then for B, this one would be -3, and then 0, 0. And this one, 0, -2, 1, and then 4 here, and then 0, 0. Okay. So now we have to multiply these together. Whew. So B and A. Okay, so since it's not a 3 by 3, this is going to be a little bit tricky. Now I'm trying to remember how we do this. Because it's supposed to be 3 by 3, 3 by 3, and it's obviously going to be a 3 by 3 matrix. So I'm guessing we're going to have to multiply these. So this row with this row and this row, this row. Well, this is a column. This is a column here. So this is going to be fun. But we're going to have to make a bigger square. This is going to be really fun. I use that very loosely, but at least these are zeros, so that reduces the workload a bit. So this one with this one, yeah, this one is not too bad actually. This one, so we are left with, for this side, is -1 plus 4. Okay, this row, so this row with this row, that's all going to be 0. This row with this row, yeah, that's going to be 0 too. Cool. So it was like eliminating everything, so that's really good. Oh, wait, I'm doing it backwards. Shoot. Oops. Because this side is supposed to be the rows. Okay, so it's gonna be this row with this column here. So then we get good so far. Next step is matrix multiplication. Multiple rows times columns. Fortunately, there's a lot of zeros. Yeah, there's a lot of zeros. when I saw what you typed before, like I didn't read it yet, but then when I saw it, I was like, uh-oh, he's gonna tell me something that I'm doing wrong here. But luckily, it's something we can agree on. Because like before, you're always good at telling me the things that I can make simpler, and I'm like, oh my gosh, that is so smart. I didn't see that. Why didn't I see that? But see, this is how math can be fun. It's just basically like you're doing a puzzle and then someone could like look over and like, oh, there's an easier way to do this. And I'm like, really? How? And then you start admiring each other based on like the level of genius that someone is capable of. Now when I say level of genius, I mean just the ability to be clever in certain parts. Of course, I do think that you guys are much genius level than I am. So let's see. So we gotta do this, and yeah, these are zeros, so that they eliminate. Now, this with yeah. Okay, I just want to make sure I do it right because I have to do it opposite way. So it's like I'm trying not to do the same thing I did last time. So this one with this one, -3 times 1, and then that's going to be 0, so that goes away, and that goes away. So basically, yeah. So that goes away, and that goes with that. Now -3 plus 1 times 1. That's 0, and that's going to be 0, and that's going to be 0. Okay, so that works. Okay. I gotta rewrite this to make it look nicer. Okay. So this row, so that's going to be 0. That's going to be 0. So that's -1 times 1. This one with this one, that's 0. That's 0. That's another 1. Okay. This one, so that's going to be 0. That's going to be +8. Yeah, so +8 here. Okay, so that row's done. Now the last one. I want to make sure that I do it right because I feel like I'm psyching myself out. So this row with this one, so that's going to be 0. That's going to be 0. -4. That's going to be 0. That's going to be 0. +4. That's going to be 0. That's going to be 0. And that's all 0. Oh, hello. Have some good math, bro. Answer. Sorry, I was just like so entrenched with the work. MJ. What's the best part of your day so far, MJ? Glad to have you here on the stream. Yeah, we're like multi-streaming today. We're doing both YouTube and Twitch. So hopefully you guys on YouTube are enjoying the stream, and as well as everyone on Twitch. Okay, I think I'm just a major stickler because I'm like, I want to make sure that I do everything right. Because the last thing I want to do is just basically like, oh, I made this mistake at this step here. Don't you guys hate that when that happens? It's like you basically work so long and you realize you just made one little mistake, then you're like, oh, where is it? Where's the mistake? This one has double, so do this one. Yeah, okay. I just want to make sure that the zeros are all gone, or like everything that involves 0 is all gone. Okay, so I think that is correct. And then this one, this one. So yeah, those go away, and yeah, that turns out to be that. Then 0, 0, then a 0, yeah. So 0. So that looks right. For tedious stuff like that, I use a calculator. I just check your results with the calculator and it's correct. Okay, thank you. Thank you, Mopord. Yeah, I know I should use a calculator when it comes to this stuff, but then I will get into the habit of just doing vector multiplication, matrix multiplication with a calculator. And I know that would be much quicker, but at the same time, I'm like, nope, I'm still not learning anything. I have to solidify it in my head so that I can tell someone if they want to learn matrix multiplication, this is how you do it, or this is how you visualize it and do it. So, you know, they're willing to do the hard work on a test, I have to do the same. Even though I'm not doing a test. I just feel like I have to solidify it in my head so that way I can understand where they're coming from as a student. Okay, so now we have to multiply that by 240. I'm gonna double check that, make sure that's correct. And in the question, yeah, that's how it's displayed. Okay, so now we have 3 by 3 times 3 by 1, which means we're gonna end up with 3 by 1, which means you're gonna go zoop, 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 and zoop, zoop. Okay. Now, let's do this. So 6 times 2 plus 3 times negative 4. And that's a 0, so we don't have to worry about that. So I think the last digits are going to go away, so we're going to get 2 plus negative 4. Yeah, because this 8 will go bye-bye, so this will go here, and then that'll be negative 16. Okay. Now the finale. Okay, so that's 12, negative 12, negative 12, negative 24. So this would be negative 6. Then will be negative 24. Okay. Now let's see if that is on our list. And I think this is number 2. Yeah, this is number 2, which means we have one more left. I see it, and I want to make sure that all the calculations are correct. Negative 4. Yeah, because I thought this was negative, but it's not. Okay. This was negative 4, right? Yeah, that's correct. And then times negative 8, and then negative 16, right? Right. Okay. So I think we see it. So let's see. Yep, that's correct. Cool. Yes. Okay. Last one. Last one, ladies and gentlemen. We're at the home stretch. Then what is TS? It should be 0, 6. Odd. You sure? Because there's a negative 4 here. Like there's a, it's negative 6 times 2 and 3 times negative 4. And they're like being added together. Unless you're just trolling. Because sometimes I will fall for that trick. If like someone basically is saying, you got the answer wrong, it should be this, I'll fall for it immediately. And I'm like, oh my gosh, really? And I would have to look back and I'm like, oh my gosh. This is 3. that's 3. Luckily, I looked back on it. T. And write it like this. And then like that. Okay, and X in this case is 1, 4, 2. Okay. You're not trolling? Okay. Yeah, because like when I just did the question and I filled in the answer, and that the answer we got was right. So either they put the wrong answer or you said 0, negative 624. So let's take a look. Because we have negative 6 times 2, and then we have we have 3 times negative 4. I'm sure that would equal negative 24, because it's negative 12 plus negative 12. I don't think I did. I mean, we checked it over twice. Oh well. I'll check it over after I do this one. So this one we have 0, 0, 5. So this one's A. Actually, we should do T first, because every time when I write it like this, I always mix it up. It has to be 8, B times C. Okay, so we'll do we'll do B first. So B is 0, 3, 0. And this one is negative 2, 0, 0. And this one is 0, 0, 4. Okay, so now for A. This is 0, 0, negative 5. This one 0, 0, 2. Oop, box is a bit small. And this one is 1, 1, 0. Okay. Now the fun part. Multiplying these together. There's a minus sign that's wrong in your calculation. Let me see. Alright, let's check this one again. So it's like, it's supposed to be this row times this column. You sure? Because we have negative 3 here. And this is like 2, and then these zeros annihilate these two. And then we have this negative 3 times 2. And that gives us negative 6. Because in this one, negative 3, yeah, we have negative 3 and 1. And I'm pretty sure I wrote these right. 6. I don't know. Maybe I have to look it over, like, because I mean it's correct in the actual like quiz sheet. Yeah, because like when we multiply these together, I made sure I did it excruciatingly close to make sure that we didn't leave room for error in here. Because like 3 times 2 is like 6. We have -6 here and we have -6 here, and then the vector we have here is like 2, positive 2 times 4. Alright, the writing proof of the main theorem and all is dependents are done. Nice, nice, well done, Sascha. But let me just get back to this problem, so that way we can like complete stuff. A has 2, not -2. I copied incorrectly. No, it's okay. It's okay. No, it's actually good because, like, you know, like, it happens, you know, like, that's why we double check everything to make sure. So either I wrote something wrong, or like, you know, I didn't want to basically say you wrote something wrong, because like that kind of feels like it's accusatory. Like, you know, I like it when people like just kind of go back and they basically find it themselves, and you know that happens, and we're human, it happens. So, you know, because like sometimes when you make mistakes and you feel like you're so certain about the answer, you have to like constantly look back and you're like wondering where it goes wrong. But when you develop that technique, it's sort of like you become a better, I don't want to say better scientist, but I guess I can't think of a better word than that. Like probably a better, like, I guess like data analysis reader or something like that. Okay, so let's get back to this. Okay. Oh. Got 0 on our first digit. That's nice. Oh, and 0 on the second digit. I'm liking that. So we're gonna get 6. Okay, cool. We're getting nice numbers. This is really good. 0. 0. Oh, this one's positive 10. Let me just double check. Just to make sure. So this one, yeah, that one would be 0. That one would be 0. This one, yeah, this one would be 6. Okay, that's good. Yep, 0, 0. Yeah, and this would be positive 10. Okay, we're correct on that, so that's good. So this one. So this one's 4. This one's 4, and this one would be 0. So let's double check, just to make sure, because we are human, we sometimes make mistakes. So this one, yep, so 0 times 0, right, yeah, that looks, yeah, that's correct. This one, yep, 0, correct. Yep, that is, I think, yep, because then this 0 will make that 0, this will make that 6, and this one will make it 0. Okay. So this one, yep, this will be 0, this will be 0, and then 2 times 5, that would make it positive 10, and then 2 times 0, okay, that makes that 0, okay. Okay, so we're just like triple checking, guys, so just be patient with me, guys. Okay, 4, 4, right, and all these are 0 times 5, 0 times 2, 0 times 4, yep, that's 0. Okay, so I think we are good there. Now, let's look at the vector. The vector we have is 4, 2, -2. You have the same result? Perfect. Perfect. And Mavort knows more than me, so if he gets the right result, I trust him. Okay, so now, so we have the reason why I write the shape of the vectors and the matrices is because it allows me to actually see where I'm supposed to aim at. I know people like basically don't do that. You don't have to do that, but I personally prefer to do that because it's like, okay, I know I have to get something that's a 3 by 1. Now, of course, I know it's supposed to be obvious, but sometimes you just want to make sure. So, that would be -12. I'm so glad we have so many zeros in this because I'm like, whew, if I had to do this like by hand, I'm gonna be like, ugh. I'm pretty sure you guys are probably like, don't like those situations either, right? Okay, so 4 times 1, and then plus 4 times 4, 16. And this will be 0, so yeah. So now we get to the finale, which is -12. Oops. -12. 20, and then 4 plus 16, that will give us 20, right? Yeah, yeah, that's correct. Yeah, 4 times 4, this 2, 0, okay. And let's see what we got. So it's -12 and -20, and then +20. And I think we did everything correct, so 12. Alright, let's check the answer. Correct. Nice. So we got all of them right. Huzzah. Nice. So we did mainly a majority of linear algebra today. So I think that's a success. And we finished one section of the linear algebra course that I'm doing, which is transformation. So huzzah, we managed to get through the linear transformations, which was a subject that I was kind of struggling with actually with linear algebra because I couldn't think of a way to actually visualize it in my head to make it solidify. So I'm kind of glad that we actually got through the linear transformation portion, because the next section of this course that I'm taking is inverses, and the inverse section looks pretty long, but probably not as long as I think it should be, because we're going to cover basically introduction to inverses of transformations, invertibility, matrix inverse. So yeah, we're going to cover that, and then after that will be determinants. So yeah, because there's like 14 sections in here, and the section we were working on was section 7. So now we're on section 8. So if we are at section 8, 14, we have like 6 more sections to go for linear algebra. So, and I think like once we get through that, we're probably going to go into probably like maybe do some multivariable calculus, because I haven't picked up multivariable calculus in a while. We do have like a couple more minutes, so I think I'm just going to do a quick glance over at differential equations, because I do know a little bit of differential equations. It's just that I want to re-pick up the basics that I learned before, so that way I don't lose the knowledge. And actually, like, this book I'm reading is by Christian Constanda. I think, I don't know if I'm pronouncing his last name right, but he did wrote a book on partial differential equations, and I've taken a glance at that book, and I think that book is like pretty well explained. So I didn't know he wrote a differential equations book, so I thought I would try to take a look at this book, see how this goes. Do you know the Benich fixed point theorem from calculus? No. I barely remember like things like the Rawls theorem from calculus, if that's the right name of the theorem. Actually, the theorems from Calc 1, I don't remember that much. Oh, I do remember I remember the names though. I think I remember the mean value theorem, but I forget what it talks about though. Why do you ask me for it? Let's see. Oh, it's actually, this is cool. Like the first sentence in the introduction of this book is actually something that encompasses this whole channel. Mathematical modeling is one of the most important and powerful methods for studying phenomena occurring in our universe. Which is why I call this channel MathSpellBook, because I love physics, but I mostly love the math in physics more. So I think that's a really great sentence here. The way this, I guess, like the way like we can like end things off. Generally speaking, such models make sense. The Minich fixed point theorem has a very intuitive visual meaning, and it is relevant for proofs and important existence a theorem for ordinary differential equations. Oh, okay. Actually, I have a small notebook here, like with me, because sometimes I do like to do stuff like off stream. So I probably will write that theorem, write the name of that. So the Minich fixed point theorem. Is that taught in real analysis? Because I don't remember ever hearing that theorem in calculus. Or is it in like Calc 2 or Calc 3? I'll just write as a side note, relevant for real analysis. Okay. Yeah, for real analysis, I have to, like, I got interested in learning things about equivalence classes, and I know that you have to know like Cauchy sequences to help, I guess, like kind of unite equivalence classes. The combination with equivalence classes and Cauchy sequences, like a proof that works with both of them, helps you prove like the real numbers. So I have to actually learn more about Cauchy sequences and stuff. So existence theorem for ODEs. Okay, that's something to keep in mind for my inspirational math notebook. Because the thing of it is that for me, I want to be able to construct math by scratch, or at least like the basic stuff that we know about math, like why is it that when we multiply two negative numbers, we actually get a positive number? And I think like when it comes to equivalence classes, I think that helps explain like, I guess, that relationship, because like mostly like in regular mathematics courses that you take like in elementary school to high school, you learn that, but you don't know why that happens. And like when you actually look at the deep proof of that, like I remember Sasha showed it to me once, and like I kind of forgot the details of it. So I know it involves like equivalence classes and ordered pairs in addition to Cauchy sequences. So I have to actually relearn that. But I think equivalence classes, as well as congruence with congruent modulus, like I have to read more about that. Let's see, calculus prerequisites. We know what a limit is, or we're familiar with what a limit is. We're familiar with what a limit is. I know I probably shouldn't say I know something, because I probably don't know all of the thing, and in math, details matter. So we are familiar with these concepts. I think when you're like an intellectual or like someone that's trying to like learn stuff, I think we have to get used to basically saying we are familiar with it instead of saying we know it. Because if we know it, then we basically will have like a very technical background in whatever it is. I think for me, I have to get used to that in my vocabulary. It's like, oh, I'm familiar with it. It's like, do you know anything about derivatives? It's like, yeah, I'm familiar with it. Instead of saying I know it, because there could be more to derivatives than just meets the eye. So let's see, prerequisites here. It's like you have to know what a limit is. You have to know what partial derivatives are. What else is here? Let's see, differential equations and their solutions. So I'm guessing, like, yeah, you have to know, like, actually the funny thing is that for me, if I were to set up my own curriculum, I probably would have set it up where I had algebra 1, calculus 1, calculus 2, and then differential equations, and then multivariable calculus. Because I think for me, it's like, it would have been better for me to take differential equations like after calculus 2, because it would have solidified my knowledge of integration techniques much easier. Because then I would be using it into much bigger things like solving differential equations. But then again, like, people can also make the argument, it's like, but you don't learn partial derivatives in ODEs. You learn them in multivariable calculus, which is a fair argument. But then again, they also teach you like partial derivatives in physics 3, I think, because they assume that the students are not familiar with it. Or I think in physics 1 they also teach it to you because they want to teach you in 3 dimensions of space. I mean, you guys can basically put your experiences in the chat, whatever it was that you went through, like learning like the material, whether it be in physics or mathematics. And I'm pretty sure everyone could think of their own method of study, whatever it is that they feel is like appropriate for their knowledge and their background. Okay guys, it's like 4 o'clock on my end, so I think that will be all for today's stream. Thank you for joining me today for our little linear algebra problem practice session for the stream. So I will be streaming next week, from like Monday, Tuesday, Wednesday. Again, apologies to you guys. I've been like pretty busy the past 2 days, so I wasn't able to stream like Monday and Tuesday. But yeah, like, thank you for joining me today, guys. For everyone on Twitch, if you want to follow me on my YouTube channel, you're more than happy to do so. For everyone that's watching on YouTube, I put all the links in the description down below for our Discord server, as well as my Twitch channel. So if you want to catch me on Twitch, you're more than happy to catch me on Twitch. And also, I will be streaming on my video game channel, my Uncle Talks channel, and that will also be in the description down below once this stream is up. And I think like you can access the description in the live stream as well if you're watching this on YouTube. So I think that will be all for today. We'll be back next week, and next week I'm not sure what math we'll tackle. We'll probably tackle more linear algebra, or maybe we'll tackle something different, who knows, or maybe I'll tackle some physics problems, but we'll see what my mood is in for that, because there's no curriculum on my channel. There's no like order I go on. I basically go whatever inspires me or whatever motivates me to actually pick up the math book and basically say, hey, I want to research this topic. But yeah, that will be all for today, guys. And always remember, everyone is precious. You guys are just as precious as everyone else. And I will see you guys next week for the next stream. So take care, guys. Bye-bye.